We're going to take a look at factoring the difference of two squares. Um, the first thing that we have to know in order to factor the difference of two squares is we have to be able to recognize what squares are. And so the first thing I want to take a look at is that squares are numbers or letters that are multiplied by themselves. Some examples are 1, 4, 9, 16, and x squared. And if you look below that, we've got 1 times 1 is 1. 2 times 2 is 4. That's what makes it a perfect square, is 2 times 2, a number multiplied by itself, okay, makes the square, which is 4. 3 times 3 makes the square, which is 9. 4 times 4, 16, and x times x is x squared. So what we're going to be doing is we're looking for situations where we have two perfect squares that are being subtracted to each other. Now, just like we've done with all factoring, what we're going to do is we're going to show you how it's multiplied together first to create the difference of two squares, and then we'll go backwards and factor it. And so below, you can see that we can do FOIL. However, on this FOIL, this is a special situation where we have the exact same x and x and 3 and 3, except one is plus and one is minus. So both of the binomials are exactly the same, except one is plus and one is minus. Well, anytime we've seen this situation, we know that all we have to do is first and last. And so when you multiply first, x times x is x squared. And then last is 3 times negative 3, which is negative 9. So every single time that we have this situation, we always know that we can multiply first and last. And whenever we do that, we always end up with a situation where we've got two squares that are being subtracted from each other. So x squared is a perfect square, and 9 is a perfect square, and they're being subtracted. And so now what we're going to do is we're going to be given the difference of two squares, and we're going to have to factor it. And when we factor it, we're going to factor it back, and my answer has to be two binomials that are exactly the same, except one is plus and one is minus. So once again, we're going backwards. So taking a look at this, I have x squared minus 25. Now these are both perfect squares. And so I know that I'm going to have to create two binomials that are exactly the same. Well, what makes x squared? X squared is made by x and x. So we took this first one and we said, okay, how do we get x squared? X and x. Then we take the second one and we say, okay, how do we get 25? Now remember, this has to be the exact same number. And so what times what makes 25? Well, that would be 5. So I'm going to put 5 in both of these. Now, if you remember from what we just got through doing, one of these has to be minus, one of these has to be plus. It does not matter which one. Okay, so when you finish factoring this, they should be the exact same, except one is minus and one is plus, and that is my answer. Okay, taking a look at another one of these. Okay, so 16y squared is a perfect square, and 64 is a perfect square, and they're being subtracted. So I'm going to create two binomials. And the first thing I have to ask myself is, what makes 16y squared? Well, first off, 16 would be 4 and 4. Once again, the numbers have to be the exact same. Y squared would be y and y. So 4y and 4y make 16y squared. Then I have to look at the second one. And so this one is 64. What times what makes 64? Well, that would be 8 and 8. And then once we have those, then one of these gets a plus, one of these gets a minus. And once again, it does not matter which. Okay, taking a look at another example. All right, so once again, we still have perfect squares. Now, I know it looks a little bit different than what we're used to because it has an x squared and a y squared, but that's okay. These are still two perfect squares. So we're going to create our two binomials. So we look at the first one. What makes 81x squared? Well, that would be 9x and 9x. So then we look at the second one. What creates 49y squared? Well, that would be 7y and 7y. And so then we just give one a minus, one a plus, and we've got our answer. So if you recognize these are pretty easy to work out, but you do have to recognize the squares, okay? Now there's one more, and I don't have this one already done, but we're going to create x squared plus 25. Now x squared is a perfect square, and 25 is a perfect square, but the reason why I want to do this one real quick is because it's not being subtracted. And if this is not being subtracted, then this is not factorable. And so in order to be able to factor the difference of two squares, it does have to be minus. It cannot be plus. And if it is plus, then we just put not factorable.